Welcome to 5G Technology World. I'm site editor Martin Rowe. Recently, annokiwave, a supplier of RFICs for beamforming and millimeter wave applications, introduced a phased array antenna innovator kit. This kit consists of a board that contains a 28 gigahertz transmit and receive beamforming IC, a 28 gigahertz transmit and receive up-down converter IC, and associated peripherals to use with this module. The module also comes with power supply, control interfaces for controlling the beam, and PC software. To learn more, we spoke with Abhishek Kapoor of annokiwave, who's going to tell us a bit about how engineers are going to use this module for evaluating the company's ICs. Abhishek, thank you for coming on. So Abhishek, can you explain to me a bit about the phased array innovation kit? For example, what is the goal of it? To me, it looks like what I would call an eval board, or what analog people or microcontroller people would call an eval board. So can you explain to me what was the motivation for developing this, and who is the intended user, and how would they be using it?
Sure thing. So we recently introduced our new generation of what we call phased array antenna innovator kit. The main intent of designing, developing, and introducing this into the market was to provide a starting platform for our customers for a complete millimeter wave to IF phased array active antenna working solution. One of the things we have realized over the last couple of years, as more and more customers are getting interested in millimeter wave 5G, SATCOM, and other areas, that phased array active antenna design is actually very, very hard. Doing that, especially at a commercial level, is even harder. So the intent of this innovator kit is three ways. One, it provides customers a very quick way to prototype and demo a phased array active antenna in a real life working scenario and get a feel of what an active antenna radio would look like, work like, and operate. Second, it gives a very good feel of antenna level performance that you can achieve with the annokiwave ICs. It's very easy to get into this whole competition of, hey, my spec is this, your spec is that, but actually seeing the antennas work in a real life working condition is a very different thing. So it allows or gives our customers an avenue to evaluate these ICs at an array level. And third, and most importantly, is to give customers a sense of the ideal performance or near ideal performance they can achieve with annokiwave ICs. We have always led the market, and we consider we continue to lead the market in performance and differentiate on many digital features. This is a way for our customers to see how they can achieve this first pass design success using annokiwave ICs. And then if they want, they can use this platform to scale their own radios to a different size, different power level, different frequency levels, and so on. Us as a company, our goal is to provide ICs that enable active antennas. This is a tool for our customers to accelerate their radio developments.
Do you see your customers using this for, they are developing base stations or user equipment, or both?
Multiple. So it's a scalable kit. The inherent architecture, the quad architecture that annokiwave IC has, inherently gives a lot of scalability. Our ICs today are used in the infrastructure world. They're used in small cell. They're used in other client-side use cases. So you can use the same design and modify this to address different use cases. As a starting point, this would be a good starting point to address majority of the infrastructure cases based on how this design has been completed. But one can very easily take this and scale this design up to meet the requirements of maybe a macro base station, or bring it very down to go into client side equipment as well. This is not intended, designed, or in any ways meant for user equipment like smartphones, but it is meant for different kinds of infrastructure use cases, small cells, repeaters, CPEs, and many other use cases. So you can scale it up or down however you want.
What do you need at each end of the radio link to support this kind of testing?
That's a very good question. So, what this provides our customers is a complete package, which includes the antenna front end, the active antenna front end. So the signals are coming in at millimeter wave if you're coming from that side, and then you have the beamforming network and all the necessary supporting structure around that, and then you have an IF up and down converter, which basically takes the signal down to an IF level to support this beamforming and IF up down functions. You also have a power interface as well as digital interface. And this digital interface can be easily connected to your laptop. And then you have the necessary control software or graphical user interface on your laptop that you can very easily use to steer the beam and run different functions. And very quickly, almost like a plug and play, have a working active antenna that goes from IF all the way to millimeter wave with a USB interface, spy control, and a power interface to just run the whole design.
And with this design, you can use this as both a transmitter and a receiver.
That's correct. It can be used both in the transmit and receive function, like a typical 5G radio, TDD.
Mm-hmm. So what would you need at the other end of the radio link to do the evaluation of your device, of your parts?
That's a good one. So different customers we expect are going to use it in different forms. Customers who are just trying to prototype how millimeter wave phased array works, and you are trying to replicate, let's say, an active antenna, and on the other side you just want a base station. You could use technically a horn antenna, and to simulate a more real life working scenario in a millimeter wave 5G world, you would put two of these antennas on each side and then have them talk to each other and do active antenna beam steering. So you could have that on the other side as well. And other customers have some very creative ways of studying how millimeter wave propagation works. So they have different setups. But the most common is you could literally have a horn antenna on the other side, or you could have another one of our kits, innovation kits, on the other side, and they talk to each other, replicating full beam steering on both sides.
So when operating as a receiver, can your beamforming IC track an incoming signal and adjust its phased array to maximize signal strength?
Using this particular kit, you will be able to scan both in azimuth and elevation, and that allows you to compensate, or not compensate, but almost track a user. So in this case, this could be the unit that's transmitting the signal towards this radio, and you can track this user by using the beam steering functions. And you're doing this all electronically. That's the beauty of full electronic active antenna beam steering, and that's exactly the purpose of this unit, to replicate that functionality, because that's what people eventually want.
Mm-hmm. Do you envision your customers using this to transmit data, or is this really more of a tool just to evaluate the beam steering and RF functions?
That's a very interesting question, because when we first developed these innovator kits, we designed it with a very different purpose. But as we have started to introduce it, we are seeing very creative ways in which people want to use this. The core principle was, hey, you can evaluate our IC performance at an array level. Well, very quickly it turned into, hey, can I take this radio and can I scale this into something different that meets my requirements? So you tweak different things and you make the design meet your requirements. Third scenario is, hey, you know what? I love this thing. This is fantastic. How quickly can I take this antenna front end and make my own millimeter wave 5G radio as quickly as possible. So we are seeing a very diverse set of opinions in the market on how people want to use it. Some people want to use it just to become familiar with active antennas. Some people want to use this as a platform to get started in their design and customize it later on. Other people just want to move as quickly as possible into a full-blown radio using this as a first step.
How can engineers use the kit's digital I/O capabilities?
At a fundamental level, the beamformer ICs and the IF up-down converters that we have a SPI interface. And that SPI interface can be used to control all the digital functions of the IC itself. Now that translates into a digital control for this entire array, which allows you to control and manage every beamformer, every portion of this entire array. And using the SPI, which actually connects to your laptop, and then you have a GUI. Now you can use this for functions like steering the beam. You can reach different telemetry data. You can steer the beam both in transmit and receive function. You can run different scan patterns. So you can pretty much do what a millimeter wave 5G radio would do, and you can simulate what your millimeter wave 5G radio could be like using annokiwave ICs. This array actually also exemplifies one of the unique things, which is how quickly annokiwave was able to design, develop, and bring this to market in first pass design success. Based on our assessment, we started and then finished this design in almost 1/3 the time of what a typical commercial company takes to develop this thing. So now with all the tools and capabilities you get in this array, now you have a very good starting platform to move full blown ahead. You have this digital control to control every function within the array itself. And then you have the flexibility to use annokiwave ICs and customize and develop your own arrays, which are very similar or bigger or smaller than this.
Can you explain how to use the power interface?
IC level, you have a SPI interface. Now, before you connect into something that is usable, I would say, which is USB in this case, you need some sort of translation or interposer card. So we provide all that hardware along with this kit that allows you to talk to the array itself, which has a SPI interface. But on the user side, you have the USB and the software and other things to control that. So it makes it much easier for the user. They don't have to figure out, okay, how do I translate what the array is doing on my end? You can pretty much use the software as well as the hardware. We are providing the cables and other translation boxes that allows you to plug and play. Literally, you can within a few minutes you can have this thing up and running to simulate your active antenna performance.
Abhishek, thank you for meeting with us today to discuss annokiwave's Phased Array Innovator Kit. For 5G Technology World, I'm site editor Martin Rowe. Thank you for watching.